Hello everyone, welcome back to my YouTube channel, The Blazing Sun. And today is the third session of the complete Python Fundamentals from Basics to Advanced course. And in this session, I am going to discuss the homework question that I gave you in the previous session. We are going to study the assignment operators, the non-data type, the uh, type predefined function, the typecasting in Python, and many more ways of assigning a particular value to the variables. At the end of the session, we will also be discussing multiple ways of swapping two variables. So let's get started. Now let's start the session with the homework question which I gave you earlier in the session second. The question is that you have to calculate the circumference and the area of a circle and display the output to the user in proper format. You have to take all the necessary inputs from the user. So first let us think what are the necessary inputs which we might require to calculate the area of a circle and its perimeter. So the only necessary input is the radius of the circle. Okay, so the radius is the only necessary input, and we will take the radius as a float value, as a decimal value, so that even if it's in decimal places, we can calculate its area easily, because we have to also keep in mind the accuracy and precision of the area. Uh, Let us code this question. So I am creating a new file which will uh, circle.py, and what they have said is that we have to calculate the perimeter, or you can say the circumference and the area of a circle. So first let me take the radius as an input. So I'm saying radius equals to, I'm taking it as an input, okay, and I'm saying to the user, enter the radius of the circle. Uh, but the input in this format will actually be in string data type and not float data type. So we have to convert this string into float value. So how we will do it is, we will say float, and within the float we are writing this whole statement of input. So this input is being converted into a float value. Now I am saying area is equals to, now I am declaring another variable of called area, in which I will store the area of the circle. We know the formula of the area of a circle is pi r square. So pi's value is 3.14, pi r square. So pi multiplied by radius, and then again multiplied by radius. So this is pi r square. Or you can have also written area is equals to pi, which is 3.14, multiplied by, you can say that we are calculating the radius square and then multiplying it by pi. So you can first calculate the radius square as well. Instead of multiplying it by 2, you can directly calculate its power by double asterisk symbols like this. This will also give you the same output. Uh, and its value will be 2 pi r. So 2 multiplied by 3.14 multiplied by the radius. Now I have to actually print the value of the area. So I'm writing print area of the circle is equals to, now after equals to and this curly after the equals to and these quotes inverted commas, I will write I will give a comma, and now I will actually give the value or the variable which I have to print. I have to print the area, then I will give another comma and then write square units. Similarly, we can also print the circumference of the circle is equals to, then we are after this, after these inverted commas I am given a comma, and then after this comma I am writing the variable name which is circumference, and what will be the unit? It will be the same unit as radius unit. Now we will run this program. Let's say the radius of the circle is 1. So the area will be pi r square, which is pi 3.14, and the circumference of the circle will be 2 pi r, which is 2 into pi into 1, which is 6.28. See, we got the correct answer. Now let me run this program again. Suppose the radius is uh, let's say 5. So the area of the circle is coming out to be 78.5 square units, and the circumference of the circle is coming out to be 31.4 something unit. Now let us see if we were correct regarding this representation of area or not. I am commenting this area and I am removing the comment from here. Now let me run this program again. I was saying that the radius was 1. See, in this case also the area of the circle came to be the same as the previous one, and the circumference also came out to be the same as the case in which we used a different notation to calculate the area of the circle. Now running the program again with the value 5. So you can see that the outputs are coming to be the same irrespective of whether you use uh, this particular notation to calculate the area or this particular notation to calculate the area. So this is actually the uh, your answer of this homework question. Now the next concept which we will study is assignment operators. Now you have seen in the previous session that when we were discussing the comparison or relational operators, uh, we introduced a assignment operator as such as equal to, which is used to uh, equal to which is used to assign a particular value to a variable. So what exactly assignment operators are? They are used to assign a value to a variable. The first and the most easy assignment operator is equal to. It is simply used to assign value to a variable. Let me give you an example. So I am saying that x is equals to 5. So I'm just assigning the variable x with a value 5. You can also say age is equals to 100. So you are assigning the variable age with a value 100. This is all about the equal to assignment operator. So the operator which I want to tell you now is plus equal to. It is plus equal to. Plus equal to is the operator, and what exactly is its description? That it adds and assign. Now what exactly I mean by it is, suppose I say there was a variable earlier called x. Now I'm writing plus equal to 5. What exactly will happen here is that x will actually become, what we are doing is we are adding 5 to x and then assigning this particular value to x itself. So the value of x will increase by 5. Similarly, we have another operator as well, which is minus equal to. Now, the what exactly it does is it subtracts and assign. Let's say there was a variable x and then I'm writing minus equal to, let's say, 2. So it's equivalent. It is actually equivalent to just writing x is equals to x minus 2. You can further, when you will study or you will practice the things, you can either use this representation in your code or you can use this representation as well. When you will become a master in coding, mostly you will use this representation, uh, but for now you can even use this representation for your easiness. The next assignment operator is asterisk equal to. Now what it actually does is asterisk equal to. What it does is multiplies and assign. Suppose there was a variable x and I am writing asterisk equal to uh, asterisk equal to, let's say, 3. So what will happen is x will actually become equal to x multiplied by 3. Okay, so you can see a pattern over here. First, what we are doing is we are giving an operator, let's suppose plus, minus, or multiplication symbols. Then we are giving an equal to. If you see uh, something written like this, it actually means that first we are adding the value, then we are assigning it to the same variable. You can notice this pattern. You can see the pattern over here, how exactly these assignment operators behave. Similarly, we have a division equal to symbol as well. The division sign and then the equal to sign. So what exactly it does is it divides and assign. So let's say there was a variable such as x, and then I am writing the symbol of division equal to, let's say, 4. So what it will do is the variable x will take a value equal to x divided by 4. So you can see the variable earlier got divided by 4, and the new value is assigned to the variable itself. Now let's move to other assignment operators as well. After divide and assign operator, I have the integer division equal to. So what was its description? It uh, actually performs integer division and then assigns its value. Suppose there was a variable such as x, and then we are doing integer division equal to, let's say, 2. So what exactly will happen is x will become equal to x integer division of 2. Now moving to other uh, assignment operators. The next assignment operator is modulus equal to. The percentage symbol, also called as modulus, equal to is the next assignment operator. So what it does is it takes the modulus, or you can say calculates remainder and assigns. Suppose there was a variable x and we are doing modulus equal to 10, or instead of 10 you can say, let's say it is 3. So what x will become is, see what it will do is it will take the variable x, it will calculate its remainder, and this value will be assigned to x itself. So the new value will become x modulus 3. Now moving forward to another assignment operator, which is exponent and assign. So you can see this is the exponent symbol, the two asterisk symbols together equal to. So what it does is it calculates uh, exponent, or you can say power, and assigns, or it's better to say calculates exponent. Suppose there was a variable x, and then we are writing the exponent symbol equal to, let's say, 2. So x will actually become equal to x raised to the power 2, or yes, this is it. Uh, Now moving to another assignment operator. The next assignment operators which we have is uh, bitwise and assign. So it is bitwise and equal to. So it actually calculates bitwise and and assigns. Suppose there was x percentage equal to, let's say, 3. So what it does is the new variable, uh, the old variable x will actually become equal to its own value, and then we are performing a bitwise operator and on it with 3. Similarly, we have a bitwise OR equal to as well. Suppose there was this variable x and we are doing a bitwise OR equals to, let's say, uh, 3. So what will happen is x will become equal to x bitwise OR with 3. So it is actually doing bitwise OR and assigns uh, the new value to the old variable. You can see a pattern in all these operators. First, we are writing the operator symbol, and then we are writing the equal to. So you can remember that first we are writing the operator symbol, so it means that we are first performing that operator on the variable, and then we are assigning that new value calculated to the old variable. Similarly, we have bitwise XOR and assign as well. So it is bitwise XOR equal to. Let's say we are calculating bitwise XOR. Uh, what it will do is bitwise XOR will be calculated and it will assign its value to the old variable. Its example is x bitwise XOR equal to, let's say, 3. So what it will do is it will do x equals to x bitwise 3. What it will do is that it will calculate a bitwise XOR of x with 3 and it will store the result into x itself. So the old value of x will get updated. Now after this we have right shift, which is this symbol, equal to. What it does is it first right shift and assign. See, these all the operators which you are seeing, bitwise AND, bitwise OR, bitwise XOR, and right shift, all these arithmetic operators as well. We have already discussed them in session second. So you can go to session second if you are feeling any trouble in these operators. Uh, the example for right shift and assign is, suppose we are doing x right shift equal to 1. So what exactly happens over here is that x, which is the old variable, will get a value equal to its original value, which has been shifted uh, by one place. What I mean to say is that there was a variable x, you shifted its bits towards right by one position, and you calculated a new value, and you stored this new value into the original x. So the value of x got updated. Similarly, you have left shift equal to as well. So what it does is it left shift and assign. You can say that suppose we are doing x left shift by 1. So what exactly happens is similar to the right shift, just in place of the right shift we are doing the left shift. X was the original uh, variable. It got left shifted by 1 and this new value has been stored in X. So these were all the bitwise operators. Now what I will do is I will code each one of them and show you uh, what they are actually equivalent to and how they work in Python. So I am creating a new file. I am saying assignment operators operators.py. I am taking a hard-coded value. Let's say I am taking the value as x equals to 10. Now this is the assignment operator, the basic assignment operator used to just assign the value, assign the value to assign the value 10 to variable x. So now I will show you whether x has been assigned this value or not. I am printing the value of x. Let's see if 10 got printed or not. See, 10 got printed. So actually the value variable x is getting the value 10. Now what I will do is I'm commenting this for some time. Now I am showing you that the first operator, which was add and assign. So I am doing x plus equals to, let's say 5. So u equals to x plus, so so you know that it is equal to x equals to x plus 5. Now let us print the value of x. So we expect that 10 becomes equal to the variable x become equals to 10 plus 5, which is 15. Let us see. Yes, it got equal to become equal to 15. Now suppose I want to calculate x minus equals to, let's say 4, which is equivalent to x equals to x minus 4. And when I will print the value, see, have commented this. So the original value of x, which is equals to 10, will be stored in x and not the new value, because I have commented this. So x is 10 over here. So we should get 6 as the answer, because x is equals to x minus 4. So x is 10. So 10 minus 4 will be 6, and just 6 will be stored into x. We got a 6. Now after this I will show you the multiply and assign operator. So I am saying x multiply y equals to 2, and it is actually equal to the old variable x equals to the variable multiplied by 2. So I should also get 20 over here, because 10 multiplied by 2 is 20, and this 20 will be stored into the original value variable x, and it will be get printed. So let us see. Yeah, we got a 20. Now I will show you what division and assign operator does. Now let's say I am doing x divided by equals to 2. What actually happens is the variable x gets updated by the value x divided by 2. So actually I should get an answer of 5, because 10 divided by 2 is 5, and this 5 will be stored into the x variable. Yeah, I got a answer 5.0. This is because Python did typecasting, the implicit typecasting on the variable x, and it turned in from integer to float. Now moving forward, the next operator which I am doing is x integer division equals to 2. So in this case, what I should get is the old variable will get updated by its initial value divided by 2, and we are taking the integer part out of it. So I should get an answer of 5, because 10 integer division by 2 is 5. Yeah, I got a value as 5. Now I am showing you this modulus and assignment operator. So let's say x modulus equals to, let's say uh, we are doing 2. So what actually will happen is the value modulus 2 will be stored into x, and it should get printed. We know that 10 is a even number, so its modulus is equals to 0, or you can say vice versa, that its modulus is equal to 0, so it is an even number. So 0 should get printed over here. Yes, 0 is the output. Now I will show you the exponent and assignment operator. Let's say x, then raised to the power 2, equal to 2. Actually, what it does is it takes the original value of x, calculates it raised to the power 2, and assign it to the x itself. I should actually get 100 over here, because 10 raised to the power 2 is 100, and 100 should be stored in x and get printed. Yeah, I got 100. Now the next assignment operator is bitwise AND. So let's say I am doing bitwise AND equals to 3. Uh, and it is actually what is happening over here is that we are taking the variable x we are calculating its bitwise end with 3, and we are assigning this value to x, and we are now printing it. So how bitwise end is calculated, you can see in my second session, the second video of this course, and easily understand it. Now I am printing the value of x, so 2 got printed. Similarly, I am calculating x bitwise or equals to, let's say, 3. Uh, what it is equivalent to is, I am calculating the old variable's value, and doing uh, so what it is equivalent to is that I am taking the original value of x, the variable, and I am doing bitwise or on it with 3, and this particular new value is being assigned to x itself. Now after this, let us see the output. 11 is the output. Now after this, I have the XOR, bitwise XOR and assign operator. So this what so the bitwise XOR and assign operator is like this. First we are writing the variable, then we are doing bitwise XOR equals to, let's say, 3. So what actually happens is that bitwise XOR of x is being calculated with 3, and then this value is being stored into x, and then this value is getting printed. Let's see, and 9 got printed. After bitwise XOR and assign operator, we have write shift and assign operator. So you know that x write shift equals to, let's say, 1 was the uh, case which we are taking now. What actually happens is that x gets what actually happens over here is that x gets right shifted by 1 place, and this new value is getting assigned to x itself. So we saw that if in the previous session, that when we are left shifting or right shifting the uh, particular value, how its new value gets calculated. So by those formulas, we can calculate that the value should be actually equal to 5, and the value of x should be equal to 5, because in case of right shift by 1, the original number will get integer divided by 2. Yes, the answer is 5. Now I will show you left shift equal to operator. When we are doing left shift by a value of 1 and assigning its value uh, to the original variable, I should actually get uh, a 20, because in left shift the number gets multiplied by 2 raised to the power something, and that something in this case is 1. So I should get 20 as the answer. Yeah, I got a value of 20. So this was all about the assignment operators. Now, after the assignment operators, I want to tell you something, that there are two more operators which are called membership operators and identity operators. We will study these two operators when we will study the data structures of Python, which are list, set, dictionary, and tuple. So when we will study these topics in the future, I will teach you these two operators as well. Earlier in the sessions, we had covered data types in Python, but there was one data type which was left. It is called the none data type, and it is a special data type which it means absence of a value. And in none data type, there is only one value, has only one special value, which is none. So in integers, you can have infinitely number of values in integer data type, such as 1, 2, 3, and so on. Similarly, in float also, you can have infinite number of values, but in none data type, you only have one single value, which is none itself. So how do you assign a particular variable with a value none? Suppose there is a variable called x and its value you have to assign none, so you will write none. Now you can even print the value of none. You can also say that none data type means absence of a value or no value or value not assigned. So to just show that the value is not assigned, we just uh, give the variable a none value. Now uh, let us run a program and see how actually none data type is printed. So I will create a new file called none data type .py. What I will do is I will call a variable. Let's say the name of the variable is variable itself equals to none. Now I will print the value of the variable. So let's see what's the output. The output is none. You can see that none got printed. Now I want to tell you one more thing, that none data type has only single value, which is none. And none means that no value is assigned to a particular variable. But there is an important note as well. Just keep in mind this note, particular note. Hmm. The note is none does not mean zero or empty strings. This is actually empty string. It does not mean false. And yeah, so none is in itself a very different kind of entity. It is neither zero, nor it is empty strings, nor it means false. So always remember this thing and never get confused what actually none data type mean. Now there is a very important keyword or a predefined function, uh, built-in function in Python, which is called type. So type is a built-in function used to determine the data type of a variable. Suppose you have a variable and you are not sure whether what kind of value it holds, that it holds an integer, a floating value, a string, a none value, or a boolean value. So you can easily use the type keyword to find the value of that data type. Let me give an example. Let's say the variable is uh, num and it has a value of, let's say, 1.02. So you can easily print the data type of num by writing type, and inside type you will write the variable. So this will actually result in the result of this particular code will be, since 1.02 is a floating value, so the result will be something like this. You class float. Uh, you have to not worry anything about class for now. When we will study the object-oriented programming, I will properly explain you what actually class is. But you can just keep in mind that, see, there is float written over here. So it is a floating value. Now let me take another variable such as, uh, let me call it num again, and it has a value, let's say 10. Now if I will print its value or its data type, I have to use the type keyword and then I will write num. So actually its output will be, as you can guess, it is an integer. So the output will be class int. Let's say there was a variable which has a name variable and its value is, let's say, true. So when I will print the type of num, I will actually get class bool. Bool actually stands for boolean. Suppose I have a variable called as word and it has some string such as, let's say, hello, and I want to print its data type. So I will use the type keyword and I will write word inside it like this. So the output will actually be class str. Now str actually stands for string data type. We have covered string, boolean, integer, float. So yeah, you can even take an example when there is a variable called x and its value is, let's say, none. And when you will print uh, the type of none, uh, the output will be class none type. So yeah, these are the examples for this type keyword. Now you can see that this particular word, which is class, is also getting printed. Can we actually remove this class word from here if we do not want this to be displayed in our output? So yes, you can do that. For that, I have a note for you. Do remember this note. You can do this particular thing by actually, suppose you want to print, let's say, uh, let me give you an example. So this is a note. For printing, let's say a variable has a value x, uh, a variable x has a value 10, and you want to print only the data type without this class keyword. So what you will do is you will write type with uh, type you will write the variable name x in the braces. Then you will put the dot operator. Then you will use two underscores together. Then name. Then two underscores again. Yes. So this will actually print int. Similarly, you can do the same thing for other data types as well. Uh, Now there's one more thing I want to tell you, that this type keyword can actually be used in certain conditions where you want to actually perform a particular decision. You have to want to take a decision only based on the given data type of a variable. So let's say, let me give you an example also. Uh, this is another note. In the form of note, I am giving you another example. Suppose there is a variable num equals to, let's say it is a value 100. Now you want to print a particular statement that num is an integer, but you also need to be sure that actually num, the variable, holds the value which is actually an integer. So what you will write is, if type of num, like this you will write, double equal to int, then you will print num is an integer. Similarly, you can give other conditions as well, and you can choose any other data type also. But according to the given data type, you need to give the particular condition. If you have given a particular, let's say a variable, a value, which is string, so you have to write str over here. If it is boolean, then you have to write bool for boolean. Similarly, if it is a floating number, you have to write float over here. Now let us code these examples. So I am creating a new file with the name type.py. Let's say I have a first variable which has a value of, let's say, 10. I am calling it variable 1, and I want to print its data type. So I can easily do that by writing type, and within the braces I can write the variable name, which is variable 1. So you can see that class int should be printed over here. Yeah, that got printed. Suppose I have a variable, let's say second variable, and it has a value, let's say 3.14, and I want to print the type of particular variable 2. So since it is a floating value, I should get a class float. Yes. Similarly, let's say there is a third variable and it has a value. Suppose it has a value of true and I want to print the data type of this particular value or variable. So I will write type, then variable 3. I will run the program. You can see that class pool got printed. Now let's say I have a variable 4 and it has a value of none, and you can print its type as well. So the type of variable 4 should actually be class none type. Yeah, that got printed. Now suppose you actually want uh, to print the uh, let's say the data type of a particular value, but you have to not use the class keyword also. You do not want the class keyword to appear in that particular type. So how we will do that? Let's say I want to print of this particular variable 4. For this variable 4, I want to print the particular type. So what I will do is I will write type, then variable 4, then outside these braces I will write dot underscore underscore name underscore underscore. Now I will run this program and you can see none type got printed. And yeah, we also know that there is a complex data type. So let's say variable 5 has a value of 2 plus 3j. Now I want to print the data type of variable 5. Let's see what will be the output. So it is class complex. Okay, now let me take an example when you want to see whether a particular number is an integer or not. So let's say you want to check for the first variable if type of the first variable 1 is equal to int integer, you have to print variable 1 is an integer. Otherwise, you will print variable 1 is not an integer. So let's run this program and you can see variable 1 is an integer has got printed. But you cannot just directly check this thing for the none data type. Let me show you. Suppose I write if type of uh, let's say I'm checking for the variable 4 which is none data type, which has a none data type. Variable 4 is equal to, let's say, none type. So see, you are able to see that it is saying none type is not defined. But when we were actually printed the data type of none, it was getting printed as none type. You can see over here, none type is getting printed. So this is not the way to check whether a particular variable has a non-data type or not. For that, you have to check by writing this condition. If variable variable 4 is none, is none. This is the condition which you should write, and then you will write print variable variable 4 is not assigned. Otherwise, you can write that variable 4 is assigned. Now let us run this program. So yes, you can see that variable 4 is not assigned got printed because it actually stores the non-data type. So there's in this we are using the is keyword. Now you can just remember this particular syntax in case of none, but we will study this is keyword in the future at the time when we will study the data structures in Python, which are list, set, tuple, and dictionary. Now I want to tell you a particular thing called as typecasting. So typecasting basically means changing the data type of a, let's say, a variable. Let me give you an example. Uh, Before the example, how many there are some categorizations in typecasting. So there are two types of typecastings. So first one is called as implicit typecasting, or you can say type conversion. In this, Python changes the data type on its own without the programmer's interference. Uh, Programmers, you can say without the programmer's interference or without the programmer's uh, yes interference, means the programmer has not himself told to actually change the data type of variable. Uh, this is actually done to prevent the loss of data. Let me give an example. Suppose I had a num1 which has a value of, let's say, 3.14, and I had num2 which has a value, let's say, 2. So when you will store a variable num3, let's say, see, this was a float number, this was an integer, but if you will store num1 plus num2, you will actually get a float as an output. So yeah, it will actually be equal to 5.14, because while addition, this 2 will be converted into 2.00. So when you will print, no need to print, I have just explained you. I have already written the this particular value. Similarly, uh, yeah, this was the case. Now let me write this particular example in form of code. So I'm doing implicit type conversion. So I'm taking num1 as 3.14. I'm taking num2 as 2. I'm storing num3 as num1 plus num2. And I want to print the value of num3. Let's see what is the output. You can see that it is 5.14 and 0000 and so on, and then 1. So yeah, it is basically a floating value. So actually the number of digits after decimal depends on the accuracy on uh, the accuracy or the not the accuracy, the particular precision uh, which the particular programming language follows in case of decimal numbers. So yeah, it will be not 5.14 exactly, it will actually be 5.000 and so on, and then 1. So I can erase this. Now there is second type of type conversion, which is called as explicit type conversion. This is explicit type uh, conversion. In this, programmer commands to change the data type so you can see that explicit type conversion does not happen itself. The programmer actually commands uh, the programmer actually commands to change the data type. So when the code is executed, the type conversion happens. Now for this, let me give you an example. So let's say I had a number num1 equals to, let's say it was 3.14. It is actually a float. Now I want num2 to store a particular value which is integer, but it is num1 which is it actually wants to store uh, the value of num1 after converting it into an integer. So it will store an integer value. So you can see 3.14 is a float. If we will convert this 3.14 into uh, integer, so it will actually store 3 as the answer. So let us actually write this particular program in our VS editor. Let's say I am creating a new file of explicit type conversion.py. I am taking num1 as 3.14. I am taking num2 as integer value of num1, and I am printing the variable num2. So let us see what will be the answer. You can see the answer is 3. You can actually even convert it into a string, and you will see that in 3.14 remained 3.14, but it was actually enclosed by inverted commas. So it became a string. You cannot see the inverted commas over here, but if you will just write type of num2. You can say class str will get printed. See, let's say num3 was actually integer value of num2. Not integer value of num2, you say integer value of num1. And now I am printing. After this, I am printing the value of num3. So yeah, you can see 3.14 get converted into 3. Let's say, let us see what happens if I am taking a num4 and it is having the integer value of the string num2. Since let us see what will the output, what will be our output. Num4, we are printing num4. You can see there is an error that you cannot convert. The error is actually value error. It is a value error. It is saying invalid literal for the int with base 10. So actually the string, if you want to convert a string to an integer, it should actually store uh, a integer kind of value within inside it. So what I mean to say is, if inside the inverted commas 1 was written, so you can easily convert this 1 into an integer. But if it was 1 point, let's say 1 2, you cannot convert it into integer. And suppose there was 1 2 3 was written, but there was also some alphabet, let's say A. So in this case also you cannot convert it into integer. So this was giving an error. Let me comment out this. Now let me see and convert uh, num5. In num5 I want to store the floating value of the num2. So what I'm doing is, num1 actually had a floating value which is 3.14. In num2 I stored 3.14 as a string. Now I want to convert that string back into float. So let's see if a string has a floating value inside it without any other kind of value such as true, false, or any other alphabet or special characters. So can we actually print that value? So let us see. Yeah, you can see that 3.14 got printed. So there is an important note for you. See, implicit type conversion happens on its own, but you need to remember this particular note. If you are doing any explicit type conversion while writing a program, so instead of note, I am giving you an example. Let's say num1 was actually equal to hello world. It is actually a string, and you want to uh, let me not call it num1. I should call it, let's say, variable 1, and I am taking another variable called variable 2, and I want to actually store the integer. I want to convert the variable 1 into integer and store this particular new value into variable 2. So I'm writing like this. So this will result into a value error, or you can simply know that it will cause an error, result into an error. So just remember that this is wrong. So do not do this kind of type conversion, else there can be an error. Uh, this resulted into a value error. There is also something called as type error. So there are different types of errors which we will study when we will study the exception handling in our future sessions. Now moving forward, after type conversion, uh, now we have a heading called more ways of assigning variables. So we earlier saw that you can easily assign a variable with a particular value. Uh, we have been assigning variables since our first or second session, like let's say num1 equals to 10 or condition is equals to, let's say, true, and so on. So this was basically very easy way of assigning, but there are some other ways of assigning as well, which can become very helpful uh, and very useful when we have to assign many variables as at once. So these ways are actually used for multiple assignments, multiple assigning or assigning multiple values at once. The first, the first method is called chain assignment. Let's say you want to assign uh, a same value to many number of variables. So for this, let me give you an example. You will understand this very easily with an example. Let's say you write A is equals to B is equals to C is equals to D equals to 100. So what actually happens is A and B and C and D, all the four of the particular variables got the same value of 100. So this is actually assigned chained assignment. Similarly, we have another form of assigning as well, which is called multiple assignment. This is called multiple assignment. Now, if you want to assign many multiple values or many different values to variables, so let's say, suppose you want to assign many values, different values to many different variables. Let's say A, B, C, such as 1, 2, 3. So this is actually what is happening is 1 will get a value, A will get a value of 1, B will get a value of 2, C will get a variable of value of 3. Now you need to keep one thing in mind. If you are assigning like this, the number of variables and the number of values should be exactly equal. Suppose you are writing A, comma B, comma C is equals to 1, comma 2. So this will actually give an error. Similarly, if you are writing, let's say A, comma B, comma C is equals to 1, comma 2, comma 3, comma 4, this will also give you an error. Now let us code these examples to understand uh, how exactly chained assignment and multiple assignment works. I am calling this particular file as assignment.py. So let's say I want to do uh, chain assignment, and so what I will do is A is equals to B is equals to C is equals to D is equals to, let's say, 100, Now I will print the value of each of the variables, and I am running this program. You can see that all the variables have got a value of 100. So this was an example of chained assignment. Now there is something called as multiple assignment as well. But uh, before that, let me comment this code for you so that these particular lines do not get executed. So now we are checking multiple assignment. So let's say I have a variable. Suppose I'm taking the same example, a comma b comma c comma d is equals to 1 comma 2 comma 3 comma 4, or you can say take any value, and now I am printing uh, the same thing, the values of all the variables, and I am running this program. You can see 1 comma 3 comma 2 1 2 3 and 4 got printed. Okay, this is correct. Now let me comment this and show you what will happen if the number of variables and the number of values are different. Let's say I am assigning a comma b comma c comma d with 1 comma 2 comma 3, and I am running this program. You can see it will give error. Now this is also a value error, but you can say it is written not enough values to unpack, which means that the number of variables are many, but the number of values is not sufficient for all the variables to get assigned. Now, similarly, this will actually result in an error. So I can write error if I will assign now. I am giving only, I am taking four variables, but I am assigning them more than four values. Let's say 1, 2, 3, 4, 5. Now you can see that again it is giving value error, but now it is saying too many values to unpack. So it actually expected four values for, but it actually got five values to be assigned. So you can see that this is also given error. So yeah, this was all about more ways of assigning values to variables. Now, since we have learned the different ways of assigning values to variables, now I have a very important uh, topic of discussion, which is also a question which is very frequently asked, which is swapping two numbers. So what I basically mean is, suppose, uh, let me give an example. Suppose there was a variable a which had a value of 4, and there was a variable of b which had a value of 5. So you wanted to interchange their value such that a got a value of 5 and b gets a value of 4. So to do this, you have to actually write a particular code. Now there can be different ways, and we are actually going to learn three different ways to solve this problem. So the first way is called using a temporary variable. First way is using a temporary variable. Okay, so let me explain this. See, we knew that A had a value of 4, B had a value of 5. Now, if after this I assign the value of B to A, so what will happen is A will become 5 and B will also become 5 because it was earlier 5. So A gets the same value as B and B remains the same. So what will happen is we will actually uh, lose the particular value of 4. So what I mean to say is, let's say uh, now if I will do A is equals to B, what actually happens is A becomes 5 and B remains 5. So you can see that A got changed to the value which we wanted it to get, this particular value. But B did not get a value of 4. So to solve this problem, uh, what we need to do is, since we are changing the value of A to uh, we are changing the value of A and updating it with a value of B. So we need to store the value of A into some temporary variable or into some variable, into a third variable, so that even after we have changed the value of A, we can use the value of A, the original value of A, to assign it to the second variable B. Now let me write the code for this. What I want to say is had a value of 4, B had a value of 5. I am saying there is a temporary variable called as temp, and I am storing the value of A in it. So you can say temp stores 4. Now what I will do is, now since value of A is actually stored somewhere safely, I can assign the value of B to A. So you can say that A becomes 5. Now, since you had earlier stored the value of A, you can take the original value of A from temp and assign it to variable B. So you will say B is equals to 10. So B becomes actually 4. Yes. You can even print the value of A and B to check this out. So this was the easiest way of using a temporary variable uh, by the method of using a temporary variable. So let us run this particular code in our VS Code editor. So I am creating a new file of swapping with temp, let's say, and the extension of the file should be .py. What I'm doing is A has a value of 4, B has a value of 5. I'm taking the temporary variable and I'm storing the value of A in it. Now what I'm doing is I'm changing the value of A and updating it with the value of B. Now I'm taking the original value of A and updating the value of B with it. Now you can print the value of A and B. So you can see A is actually equals to the variable A and B is actually equals to, we can run this program to print the values of A and B. Say there's some mistake over here. Temp has A. Okay. B should actually have the value of temporary variable. So by running the program, you can see that A, which was earlier 4, got a value of 5, while B, which was earlier 5, has got the value of 4. So we have basically swapped their values. Now I will show you the second way of swapping the value of variables, which is actually a mathematical way of swapping the variables. And I encourage you to actually learn this. It is actually a mathematical uh, way of swapping. Suppose the variable A had a value of 4. I am taking the same example. And B had a value of, let's say, 5. Now I want to actually change the value of A and B. So what I will do is, in A, I will store the value uh, of A plus B. Then what I will do is, I will update the value of B with A minus B. Then what I will do is, again I will update the value of A with A minus B. So I encourage you to learn this. Now I will also explain you the logic behind it. In this code, you can also write these in the form of assignment operators, such as uh, A plus is equals to B, and this should be written as B is equals to A minus B only. Don't make don't make it a mistake by writing B minus is equals to A, B minus is equals to B, because this is different from that. And then you can write this as A minus is equals to B. But this is simply the same thing. Now let me explain you this with an example. Okay, so I'm explaining you. Uh, so see, earlier A had a value of 4, B had a value of 5. So what I'm doing is, I'm saying, hey, A, can you store the value of yourself and add the value of B to it? So what I want to say is, A, can you add your value to B and store the particular new value in yourself? So A actually stores now 4 plus 5, which is equals to 9. Now I am saying, B, can you take the new value of A and subtract your own value in it and store the new value? So what I am saying is, B, can you take the new value of A, which is 9, and subtract your original value, which is 5, from it? So can you actually store 4 in yourself? So you can see that A became 9 and B become 4. So we have actually got the value of B which we wanted. So B has got swapped. But since A should also become 5, so what I will do is, hey, A, you who are actually 9, so you are A, and I want to uh, uh, minus, I want to subtract something from you. So what should I subtract from your new value so that I get B? So I should actually subtract your original value, uh, which is stored in B now. So I should subtract B. So what actually happens now is, A, which was storing 9, you are just subtracting 4 from it, and now you are storing 5. Now this is a very clever way of swapping the variables, and I encourage you to learn this. When the question states that you cannot use a third variable to swap two numbers. So you can see that got a value of uh, B got a value of 4 and A got a value of 5. So yeah, A became 5 and B became 4. So now let us write this particular example in the form of code. So I'm creating a new file which is called swapping without 10. What I am doing is I am saying A, you are 4, B, you are 5, or you could have assigned them by the multiple assigning method as well. A comma B is equals to 4 comma 5. Then you could have done A is equals to A plus B. You can do B is equals to A minus B. Then you can do A is equals to A minus B again. Now you can print the values of A and B. A is equals to then A, and then B is equals to then the value of B. This is how you will print both the values in a single line. Now let me run this code. So A should get a value of 5 and B should get a value of 4. Yeah, A got a value of 5 and B got a value of 4. Now there is a third special way of swapping these variables, a very special way of swapping the variables which exist in Python. Uh, so this is also called Pythonic way of swapping variables. Let me write the third example, third way, Pythonic, because it is specially in Python, Pythonic way of swapping. So what exactly it is? We have studied multiple assignment of variables, such as you know that A comma B we were assigning as 4 comma 5. Now what we can do is to just swap the variables. We can just write A comma B is equals to B comma A. So what will happen is A will get a value of B and B will get a value of A. So actually A gets 5 and B gets 4. So there was no, you can say, kind of collision of the values. There was no problem in the assignment of values because they got assigned independently. So A got a value of B and B got a value of A simultaneously without any problem in a single statement. So this way of assigning the values is called Pythonic way or Pythonic way of swapping. Uh, I encourage you to actually learn this way because it will come in very handy when you will write particular program to swap two numbers. Because see, in the first method, you had to actually use the third variable, and also it is very not very helpful to write too many lines of code. Similarly, in the third, it was very complex way, mathematical way to swap the numbers by this mathematical operation. But the third special way of Pythonic way is very easy. So, and it swaps the variable in a single statement. So I encourage you to learn this. You should also know and understand the others and keep them in mind as well. And now let us code this Pythonic way of swapping. So I'm creating a new file and I'm calling it Pythonic way of swapping. Pythonic way of swapping .py. Let's see. Now I'm assigning two values a comma b is equals to 4 comma 5. Now what I'm doing is a comma b is equals to b comma a. You can please notice that first I have written over here a comma b. Then since I have to swap or interchange their values, I have written b comma a. Do not write a comma b over here also, otherwise there would be no change in the values. You have to write b comma a. Now what I will do is I will print their respective values. So a is equals to, I'm writing a, then I'm writing b is equals to, then I'm writing b. So let me run this program. A got a value of 5 while b got a value of 4. You can see a was 4 and b was 5. Now a became 5 and b became 4. If you learned something new today, please like, share and subscribe to my channel. See you in the next video. Thank you.